Hi, Fatuma. Good morning. All right, good morning and welcome back to the best class of the day. Hope you guys are doing well and staying safe. Please check the attendance to the left. Please make sure it's accurate and precise. Looking for Jessel and Amaya. Jessel and Amaya. If you're here, just let me know. Chat, unmute, whatever you have to do. All right, so here we go. The COVID update for today. There's Jessel, of course. Hey, Jessel, try to get here a minute earlier if you can, please. COVID update for today for Oneida County. Here we go. Let's check out the dashboard. Again, this is the Oneida County dashboard that was created just to inform us. There are 3,946 cases that are active cases in Oneida County. That means there's that many people that have COVID around us. Let's go through some more data. Here's something I haven't really checked out before, but it's positive percent cases in county by facility type. So obviously that big chunk right there is a big one, 53%. It's a big category. All other facilities, but nursing homes up there for percentages of them. All the cases, 11.9% are coming from nursing homes. Schools are 3.6%, not a huge percentage. I don't know. It's an interesting little chart there. Check out some more stuff here. More information. Hospitalizations down to 134. I don't know. Like 2 weeks ago, there's 34 cases in the hospital. Now there's 134. ICU patients, there's 14. Deaths, there's 178 deaths who passed away from COVID. And that percentage rate, I'm not sure about the percentage rate, how much I believe it, because I'm seeing different numbers on different media sources. So I'm not sure. It's 2.4 from this site. WKTV comes up with a number that's 8.5. So that's a big difference there. Last couple weeks of data, here we go. The 14th, there's 179 cases. The weekend, there was, so that's Monday. Sunday, there was 137, and Saturday, there's 201. Previous day, 255, and 293 last Thursday. So there's a little update. You can see where it is. Tons of people have COVID around us in the community. Again, I'll say it again and again and again. Protect yourself, protect your loved ones. Wear a mask, social distance, wash your hands. Don't let that virus on your body. Keep that virus out of your house. All right, so there's a COVID update for today. Let's check out our daily agenda. All right, so here we go. Happy Wednesday. I have not failed. I've discovered 10,000 things that won't work. Thomas Edison said that one. I may have used that one earlier in the year. I can't recall, but I think I might have. The daily agenda for Wednesday, December 16th, 2020. It's a day 2 today. We have chemical bonding. We're going to continue on. We will finish up ionic bonding in the next few classes, a couple classes probably. We're going through topic number 5, which is mole calculations. We'll start off with a warm-up. I dated this wrong again. So it should be the 16th warm-up. And then guided notes and exit pass you should be able to complete on topic number 5 at the duration of today's class. Then we'll get into topic number 6. We'll go through some guided notes, watch a quick little flick. Then you'll have examples and an exit pass. That will probably be next class. You'll be able to do that. All right, so please start off and find the warm-up. And it is dated correctly on the docs when I did it, or the forms. So please click on 12, 16, 20 warm-up. 12, 16, 20 warm-up. I'm in the wrong class. I'm late for class. I'm sorry, guys. Looked a little funny. We just switched classes. Same agenda, though. 12, 16, 20 warm-up. All right. All right, there are 6 questions here today. I'm going to ask that you do the first 5 only because 5 and 6 are the same exact questions. but please attempt questions 1 through 5. Try your best. Some of these I pulled out from earlier in the unit. Some of them are middle unit, and some are from yesterday's class as well. So please take the first five questions. Please complete it. And today, since they're a little bit more math intense for some of these, like number 5, I'm going to give you 10 minutes to work on this. So at 9:30, 9:46, I will review these questions. Please attempt them. Whatever you put into something, folks, is what you get out of it. If you're just logging in and doing nothing, don't expect to go out of here and learning any material. So at 9:47, let me give you an extra minute there. 9:47, we will review the warm-up. Please work on it. Okay, hopefully you had a chance to go over and actually attempt the questions for the warm-up for today. All right, let's check out some examples here and see how we did for the assessment. Question number 1 says, which pair of elements form an ionic compound with each other? Please put the answer in the chat for number 1. Which pair of elements form an ionic bond with each other? Please put the answer in the chat privately. Thanks, Jen. Thanks, Chitso. Thanks, Nadia. Thanks, Nina. Ita, Evan, good. Thank you. So I got a bunch of answers just rolling at me, and everybody picked A. So it is A. Again, ionic bonds of metal and non-metal. We should definitely know location of metals, definitely know location of non-metals. Ionic bond, metal, non-metal, bonding together. So a little refresher again, ionic bond metals are all the way to the left of the staircase. These guys are all metals. Non-metals are to the top right of the staircase. Those are metals. Non-metals would be up in this portion area, kind of this area. He and H are non-metals too. So 1 is A, definitely. Number 2 says, what is a correct formula for iron 3 phosphate? Iron 3 phosphate. Please put the correct answer for number 2. Thanks, Evan. Thanks, Shitso. Ta, thank you. Nina, thanks. A few more answers. Thanks. Fatuma, thank you. Oh, Fatuma posted everybody. Fatuma says D. Pretty solid. Just confident with that to everybody. All right, so let's check out this one. I have C's and D's as answers. That's okay. Let's see.
Are we doing 1 or 2?
Number 2. Question number 2.
So which one's number 1?
1 we got was A. 1 was A. 2 we got iron 3 phosphate. What'd you get for number 2, Edmund?
For number 2, I got I wasn't sure if it was right, but I had B for it.
All right, let's check it out. So iron 3 phosphate. So iron's definitely Fe. That 3 represents a charge. So I have several answers for number 2. That 3, that Roman number 3 represents that charge at the top. Phosphate is going to be phosphide would be a binary compound, or it'd just be just a P. But phosphate is going to be a polyatomic ion. So it's not phosphide, so it's not A. 8, so if we check out page 2 of the reference table, phosphate, there it is. That's PO4 with a -3 charge.
Oh, so it had to be D.
It's getting closer. Let's see. Oh, great. That didn't work out well. My mouse, I dropped my wireless mouse, and now it's like all shot. PO4. And the charge is -3. Take those 2 charges and crisscross those charges. That goes outside parentheses. Take the absolute value, cross those charges. Formula would be Fe3. Oh, it's horrible. Fe3 PO4 3. That would be a molecular formula. That's not a choice up here, though. It's definitely not B, because we don't have PO4 phosphate. C or D is one of these guys. So that would be a molecular formula right there. An empirical formula, if you divide them out by a common term, this is Fe3PO43. Common term here is 3 and 3. If you divide both of them by 3, divide both sides by 3, that's going to cancel to 1. That's going to cancel to a 1 as well. So Fe1PO4. So if you pick choice C, which I got a lot of answers for that one, choice C is the right answer for number 2. Hopefully that clarifies some of the missing links there. Number 3 says, what is the empirical formula of the compound whose molecular formula is sugar, C6H12O6? So what's the empirical formula for that, please? Thanks, Jessel. Looks good, Jessel. Thanks, Fatuma. Looks good. Oh, she posted confidence again. Fatuma, I like the confidence throwing to everybody. Now everybody's jumping on the bandwagon. So thank you. Rita, thank you. Jen, thank you. All right, so choice D. Some people, everybody put choice D. Does anybody want to see why it's choice D? D's the right answer. If you submit an answer, you put D, that's the correct one. You want to see why? All right. Choice D is the right answer. Number 3. Find the common term is 6. 6, 12, 6. What's the common term? Is 6. So divide everything by 6. Choice D works out. Question number 4. I think you saw a question similar to this before. Given the incomplete equation, the compound is represented. Which compound is represented by X? Please put the answer in the chat. Thanks, Edmund. Thanks, Jen. Thanks, Lena. Thanks, Shitso. Thanks, Eita. Okay, I didn't get a ton of answers rolling in here, so let's check this one out as well. You did see a question similar to this before, though. So let's check it out. In this equation, in this example here, you have a chemical equation. In the chemical equation, you have a reactant and a product. So again, the reactant is to the left. Reactant yields a product. Reactant to the left, product to the right. So the first thing you want to do here, this is like a mathematical expression. They're both going to be equal. So whatever's on the left side is going to equal the right side as well. The first thing I do when I have an equation or question like this is I put a line like right down the middle from my reactant to my product. So then I can compare all the ions or elements in the reactant versus the product. If I check out each element here, going through the process, you have Fe. How many Fe's are present here? There's 4. And then you look at the oxygen. How many oxygens are on the left side? 3 times 2. That would give you 6 oxygens. So I have 4 Fe's. Oops. Uh-oh. 4 Fe's and 6 O's. To the right side, I'm going to need Fe. And I'm also going to need O. So those two have to be present in the compound. Or Fe and O. So if I start off with Fe and O, so I'm going to rewrite this for a second. So Fe and O, we have Fe and O. That coefficient 2 is going to be, has to be on the outside. That is going to be the same. So I'm just going to get rid of this. It's going to kind of work its way over. Make the arrow over to here. So right now I have 2 Fe's and I have 2 O's. So I have 2 Fe's, 2 O's. They're not equal though. So both those situations, not equal. Not equal. How do I make my Fe equal to 4? I'm going to have to add a subscript of 2 there. So 2 times 2 would give you 4. So how do I make my oxygen into a 6? 2 times what gives you 6? 2 times 3 would give you 6. So now those are equal. Those are equal. Nope. That should be 6, not 3. Those are equal as well. So the formula is going to be Fe2O. Fe2O. So checking on out, Fe2O, choice B. If you put choice B, you're correct in that one. That's question number 4. The last one, number 5. 5 and 6 are the same question. Which quantity is equivalent to 39 grams of LiF? Please try that one out. What'd you get for an answer? That's okay, Fatuma. I thought you were being confident, just showing off what you know to everybody. That's cool. That's fine. I'm not judging. Thanks, Jitso. Thanks, Lena. Thanks, Fatuma S. Wow. Thanks, Jen. A lot of common answers here. Pretty impressive. All right, so this was yesterday's topic and a lot of similar answers here. A couple A's and a lot of D's. All right, let's hammer this one out too. So this question right here, let's figure out how to do this one. Which says, which quantity is equivalent to 39 grams of LIF? So in this question, the first thing I would do is highlight the important information from the text. It has 39 grams, and the compound we're analyzing is LIF. And there's one more piece of data. If you look at choice A, B, C, D behind, it's telling you the units are moles, but I'm not going to get rid of this whiteboard behind me. It's moles are also there. So I highlighted the important information. Now I have this right here represents a mass. This is a compound. I probably get a GFM from that, gram form of the mass. And the other thing I have, I'm looking for the units here are moles. So behind this board, it says moles. So again, mark it on up. My mass is equal to 39 grams. I have a LIF, which I could find the GFM from that. And then a number of moles is what you're looking for. So that's given information. The formula you're going to have to use is going to be on the reference table. Last page of the reference table, it's the second one down. Formula is number of moles equals given mass over my GFM. So hopefully this rings a bell from yesterday's class. Gram form of the mass. Plug it on in. Number of moles is what you're looking for. X. Mass is equal to 39 grams. And then the GFM, I'm going to have to calculate. So that GFM, we'll have to solve for that. How do you solve for the GFM? LIF. Here we go. Let's do it. So I'm pulling out the reference table. You need the reference table handy for today's class as well. Oh, great. LIF. So LI is the mass. It's on an angle. It's rotated. Li is a mass of 6.9. So we have 6.9. So what I would do is LIF. How many LIs are present? There's 1. The mass of Li is 6.9. This is how you calculate GFM again. Multiply both those together, you get 6.9. And F, how many Fs are present? There's 1. The mass of F comes from the reference table. F's mass is 19.0. That rounds up to 19. Hopefully you can still follow me. 19.0. Add up your GFM. 19 plus 6.9. 25.9. 25.9. Wish I had a pen or paper in front of me. So that 25.9 goes right here for the GFM. 25.9. 25.9 is going to go right there. Divide those two things out. Obviously 39 divided by 25.9. 39 divided by 25.9. Let's finish this one on up and switch on over. The Zoom screen doesn't really want me to do it, I guess. Because if I get rid of the whiteboard, then it's going to look quite a bit different. So 39 divided by 25.9. Get an answer of 1.5 moles. 1.5 moles. So you calculate that, you get 1.5 moles. Choice D was the right answer. Does anybody have any questions on the warm-up for today? No, it took some time to go through and go through the questions as well. All right, hopefully you're attempting these. Hopefully you're putting your own effort in and being successful with them as well. All right, so there's a warm-up. Let's switch gears on over to our note packet. So please open up your note packet. For Unit 5, Chemical Bonding. Pink blanket's still behind me. A little heads up, they're calling for like 3 to 6 inches of snow tonight, so get those shovels ready. Brace yourself. It's going to be winter real soon here in central New York tonight. All right, I'm not going through this whole routine. Obviously, my pages keep adding up more and more. I'm at 24 pages right now before I even got to covalent bonding. But you should know all this stuff about ionic bonding. If you need a review, feel free to review this on your own time. You can just go through your notes. Hopefully you can relate to it. You hear me going through those every few days or so, but I'm not going to always go through that each and every day. All right, from my end, I am on page number 15. Page 15, and we left off last class talking about how many moles. So talking about moles, I gave you that formula, and a lot of you guys actually put the correct answer for the last one, so you know how to calculate that formula. Today's class, we're going to go further in with this formula. What's going to happen, we're going to start off by just taking that formula and just getting mass alone. So we're going to convert to mass by itself. So let's scroll on down. Example number 3, but before we do that, there's a formula that we have to interpret. I'm going to switch this and put this on the next page just so it's all together. Converting moles to grams. So next up, we're converting moles to grams. We're rearranging the mathematical equation just so it's going to be moles to grams. So you have that calculation. All right, so converting moles to grams, I'll just give the equation for now, but then we'll figure out how to get this equation. It is actually on page, the last page of reference table, table T. It's not given to you directly, but you can easily calculate for it as well. All right, so inside this cell, we're gonna put the formula. It's gonna be mass, I'm gonna center it, bold it, blow it up. So it's going to be mass equals number of moles times the GFM, gram formula mass. So again, gram formula mass is not going away, so hopefully you can calculate the GFM. Sometimes they'll be given to you in the passage, sometimes you have to solve for it on your own. So moles to grams. Moles to grams. That's going to be grams. Let's check out our example here. Example number 3, question reads, a 2.45 mole sample of KCl will have what mass in grams? So this is a Regents type of question. Might be a part 2 question, might be a part 1. We'll see. I don't know what's going to happen here. So we have, first off, I'd approach it the same way you approach all of these questions. Figure out what the heck is given to you, figure out what they're asking you to solve for, and then find your approach. You have 2.4 mole sample. that first number represents moles. So that is definitely an important piece of information. We have KCl, so that's going to be a compound they're analyzing. You could definitely get a GFM from that. And it wants to know, what is the mass in grams? So come Regents Day, you're stuck, you don't know what to do. I would highlight the information that you have, and then you could figure out a smart approach to finding the answer. There's not too many formulas that they're going to ask you to memorize yourself, but there's a couple, like neutrons, that's one of them. Or atomic mass, how to calculate atomic mass, that's another one. So I would take this information, now I'd look at the last page of the reference table and say, oh, let's figure out what the heck, how we're going to approach this and find a formula for it. Last page of the reference table. I have moles, I have KCl, and I have a mass. So scrolling through it, looking for moles, KCl, or a compound, and a mass. So moles, there's moles, mass, but then you have KCl, which you could have a GFM. You can find a GFM from KCl. So it's got to be some way or another. It's got to be that formula. So I'm going to write this information down to the given information. Given information, I have moles. I'm going to copy and paste it. Control C, copy. Control V, paste. That represents the number of moles, or the moles. So number of moles equals 2.45. Mass is what you're looking for. So I'll make that my X. Copy that one and paste it below. That's the given information. Looking for the mass, and we also have the KCl. So obviously you're using the formula above, so I'm going to copy and paste that formula above. You could use the formula in the reference table. I'll show you for the next one how to calculate this one right above. All right, let's plug in some information. You are looking for a mass. Guess I'll color code this so you guys can make those connections there. Number of moles is given to you. And the GFM is not directly given to you, so you're going to have to calculate for the GFM of the compound. So you can match that up. I'm going to copy and paste that formula below. I'm going to fill in some information. I guess I'll call mass my X. Number of moles, I'll fill that in with 2.45. And then now I'm stuck. You can't have two unknowns to solve this expression. So we have to figure out the GFM. Again, the GFM comes from the reference table. How do you do the GFM again? So the GFM of KCl. You look at each ion, you have a K. How many moles of K are present there? 1. Then you have the mass of the K. So now I have to use a reference table, find the masses of these things. K has a mass of 39.1. Take your mass of 39.1 times the number of moles. That equals obviously 39.1. Then you also have Cl. How many Cl's are present? 1. The mass of Cl is 35.5, which comes from the atomic mass. Total GFM. Last thing I do is add them both together. So hopefully you calculate the GFM. If you need more explanation on this example, scroll on up to GFM portion of your notes and you can find the exact example for KCl. So I did that relatively quick because it's already done in your note packet. So I have both those together. I got a GFM, a total GFM of 74.6 AMU, or grams per mole. AMU or grams per mole, either one of those. I like AMUs, atomic mass units. So that 74.6, not 5, is going to go up in the GFM. So now it's super simple. All you got to do is multiply those two values to get the mass. Multiply 2.45 times 74.6. X is going to equal 182.77 grams. Or to the least precise measurement, 182.8 grams. Either one of those answers would be acceptable for the regions. Converting moles to grams. That's how you do it. Use that one calculation on the reference table. But again, this calculation is not directly given to you, but the mole calculation is. So this time I'm going to show you how to calculate this with the mole calculation. So one more example here for moles. I'll show you how to calculate it this way as well. Does anybody need more time?
I need more time.
Okay, no problem. Anybody do anything fun and crazy? Get your skis all waxed up and getting ready to go down Val Bialis, the Parkway Ski Center. I don't know if it opened up last year. Another city has a ski resort in their downtown, the heart of the city. It's pretty cool. If you want to see something crazy, I'll show you something crazy. I'll show you crazy, Mr. Brown, maybe. What's that about? Not that. That guy's not crazy. For a nice little workout this morning. Just killing some time while you guys catch your notes up. And this was pretty cool this morning. I drove on by. I'm like, oh, look at that nice sunrise. Things you see in the morning. South Utica Higbee Road. Oneida and Higbee's like right there. That's the intersection of Oneida and Higbee. It's pretty cool. Nice, very bright pink. And I pulled over. I wasn't taking a picture. I was driving. I'm very responsible in that. Pulled over. Looks like I'm in the middle of the road, but I'm not really not. But that's it. That's all I got for you. Did you have enough time? Do you need more time? I don't know who said they need more time, but if you need more time, let me know. I'm going to continue on because I haven't heard from you. All right, the next example is going to be example number 4. Now we are converting 0.344 mole sample, and we want to know what that's going to be in mass in grams. So I want to know how many grams is going to be out of that sample right there. So again, I'm going to approach this the same way I approached the last one. Figure out what do you have. What do you have? I have 0.344 moles. I have the compound CaNO32. So I'm going to highlight that. So if I had a piece of paper in front of you, or this packet in front of you, or a Regents question in front of you, I would say just underline it. You could use a highlighter on the Regents if you wanted to, but your final answers cannot be highlighted. So that is a compound we have, and we want to know what mass it's going to be as well. Usually schools don't supply the highlighters, so if you want to bring a highlighter and kind of highlight it like this in different colors, feel free. You could do that as well. Good approach. So now let's figure out what the heck we have. We have 0.344 moles as given information. What does that represent? It represents moles. Just copy it and paste it. Moles equals 0.344 moles. I am looking for, again, mass in grams. So we are looking for mass. From my experience, Google Docs does not like long papers. The more information you have here, the more glitchy it gets, or the longer it takes to have input in there. Maybe it's just my end. And then the compound we're analyzing is CaNO32. So this, we'll pretend this Regents Day with this question. This Regents Day, New York State says, hey, let's try out the Regents and see how the virtual world worked out. Let's see if it worked out for anybody. I don't know what's going to happen, folks. No idea. So Regents Day, you're trying to figure out, you have all this information, and then I would say, hey, check out the reference table and figure out what formula you can use. So I'm checking out the reference table. The last page of the formulas. I have moles, mass, and a compound. Can't be density. Moles, mass, GFM. Maybe you're like, what the heck's a GFM at that time? Maybe it's that one. So let's scroll on down. So maybe I'll like put a check mark here, say, oh, it could be that one. Percent error, no, it's definitely not percent error though. Percent composition by mass, part over whole. There's nothing with moles there. Can't be that one. Molarity, oh, there's a mole. Maybe it's that one. Moles of solute, maybe. But liters and mass, they're not the same units. And molarity, no, it's not going to work out there. It's not going to be combined gas laws, pressure, volume, temp. It's not titration of molarity and volume. There's no volumes there. It's not heat. It's not temp. So you really like dumbed it down to two different formulas that it could potentially even be. So by just approaching it like that, it's got to be number of moles or it's got to be moles of solute. Hopefully you can figure out it's going to be this formula right here. Number of moles equals given mass over GFM. It is going to be that formula. So Regents Day, I'm going to copy that formula down. My formula is going to be number of moles. Number of moles equals given mass. I'm just going to put mass. I'm going to press Control U first. Mass. I'm going to hit Control U at the end of that. Press spacebar about 5 times. No, not times 100. Mass over GFM. Jumping ahead of myself. Percent comp. Gram. Formula mass. Let's blow this up so you can actually see it. So that is a formula that we are going to use. Regents Day, we finally found an approach. We've said, hey, it's got to be the number of moles equals mass over GFM. You don't have to color code this. I'm color coding it so you can figure out where these values come from. So mass is going to be the unknown value. And then GFM has to come from the compound. That might be the harder thing to figure out. GFM, formula mass, something you're just going to have to memorize and figure out how to do GFM. Spent a lot of time talking about GFMs. All right, so now we can plug it in. So I'm going to copy this formula and paste it below. Control C, Control V. Number of moles is 0.344 moles. Mass, I'm going to call that X because we're looking for that unknown value. And the GFM, I got to figure out this GFM is going to be gram formula mass. So that's going to be like 1 mole Ca times the mass plus 2 moles of N times the mass plus 6 moles of oxygen times the mass. But we already did this one before. We did CaNO3 before. I think we actually did like 2 or 3 times already. So I'm not going to do it again. I'm just going to scroll on up, find CaNO3 2, find the GFM of it because that's not going to change. CaNO3 2, there it is. You can take this one or you can take the one from the GFM. So I'm not going to do it for a third time again. There it is. You can take that one if you want. I don't care which one you pick. I'll take that one. I'm going to copy and paste it just so you know where that GFM came from. I'm going to paste it right below just so you know where that information came from. You can stretch out these cells if it's not in the same line. Grab it from the top and just stretch it. All right, so that's the GFM, 164.1. I'll take that 164.1, plug it on in. And then I think you should all be able to do this equation now. 164.1 grams per mole or AMU. You have to solve for X now. So all I have to do is solve for X. How do you get X alone? So X alone, all you have to do is cross multiply your values. So in this situation, cross multiply, if you want to put this over something, you can put it over a 1. Cross multiply here. Take your 0.344, multiply it by 164. That's going to give you a value. That's going to equal X. So again, cross multiply. I don't know if they call it cross multiply in math class or what, but back in my day, they called it cross multiplying. Back in my day, I used to walk to school, 2 miles of school, a foot of snow. Just kidding. But it's like something old men always say. I'm an old man, I know. So you're cross multiplying. Take those 2 values, cross multiply. Please let me know what the answer is when someone gets an answer there. In the chat, on you, I don't care. Please cross multiply. Thanks, Ita. Thanks, Lena. I was worried about that math. Thanks, Evan. Yeah, so 56.5 is a good number. 56.5. So you cross multiply those 2 values. I got X equals 56.45 grams. You could represent it like that for the regents, or a better answer to least precise measurement would be 56.5 grams. So the mass in that situation, 56.5. So that formula above that I gave you is not given to you, but this one right here is, the one that we just put there, that is given to you. You just have to rework that formula around to solve for that missing link. And you can do that. Questions on topic number 5. All right, about 25 minutes left of class. I'm going to start topic number 6 because I'm going to try to catch you guys up a little bit more with my other classes. That's not a big deal, but mentally for me it would be. Does anybody need more time or any explanations on example number 4? All right, let's go to the next one. Topic number 6. So more stoichiometry, some more math expressions we will analyze. Topic number 6, our objective for the rest of today's class and next class is going to be determine the percent by mass of an element or ions in a compound, determine the percent composition by water by mass present in the hydrate as well. So next up, percent composition. Pretty easy formula. It's just some math here. It's going to be in table T. The definition is going to be the proportion by mass. So proportion by mass of the element in a compound. Proportion by mass of an element in a compound. When determining percent composition, it's going to be a quantitative analysis. It's going to tell you how much of each element is going to be present within a compound. Yes, there is a formula last page, a reference table for percent composition, but there's only one of them. What I'm going to do, I'm going to give you like 3 different formulas that are similar, but they're all going to be relatively the same for percent composition. There it is, percent composition. Percent composition is going to be the mass of the part over the mass of whole times 100. So mass of part over mass of whole times 100. Small number over large number times 100. So don't think there's a way I could copy them. Maybe I could, but you probably can't. So the formula is going to be percent composition composition I'm going to hit Control U to underline mass of part. I'm going to hit Control U again, press spacebar about 5 times, multiply that by 100 because you have to multiply it by 100. Mass of part, and then underneath them put mass of whole. Small number over big number times 100. That formula is given to you on the reference table. So another formula that we're going to highlight. Should be able to understand this formula by the end of today's class. So we'll see this formula real soon. The experimental determination is going to be very similar to that formula. So what I'm going to do, just for the format, I'm going to copy that whole formula when you're done. Copy this formula and paste it below. We're just going to tweak it a little bit. So copy, Control C, paste it into that cell, Control V. If you want to paint a different color, go for it, just so you know it's a different formula. Experimental determination, the formula is going to be the given mass, or the mass of the element, over the mass of the compound, like the GFN. Times 100. Let's check out one of these examples, see how to do it. Sorry, there's such a lag in my system right now. Okay, here we go. The example for percent composition. Question reads, a compound containing nitrogen and oxygen has a mass of 80 grams. Experiments show that 80 grams is made up of 56 grams of oxygen and 24 grams of nitrogen. What's the percent composition by mass of each element in the compound? So that's the question. I'm going to reread it again and highlight important information. A compound containing nitrogen and oxygen has a mass of 80 grams. So total, the N and the O equal 80 grams. Definitely important information for us. Experiments show that 80 grams is made up of 56 grams of oxygen. So the oxygen is 56 grams. And 24 grams of nitrogen. 24 grams of nitrogen. That's important too. What's the percent composition by mass? Percent composition by mass of each element in the compound. And that's what you're looking for, percent composition by mass. Each element in the compound. All right, so let's go. Let's figure this out now. So all this is given information. I'm not going to rewrite it to the left. It says percent composition. It's got to be one of these first two formulas. They're both real similar. So I'm just going to take this last formula. I'm going to copy it. Hopefully I had a chance to copy it all down. I'm going to copy it, and then I'm going to just paste it in the cell below. Control C, Control V. Make this smaller, and then I'm going to color code this a little bit. Percent composition, definitely going to be teal. Mass of each element. So we'll start off with oxygen. And then the entire compound has a mass of 80. This is going to be my blue. I'm going to copy the entire formula, and then I'm going to tweak it with my information. Copy, press enter a couple times, and paste it. We are looking for percent of nitrogen. Percent composition of nitrogen. The mass of nitrogen, N, so this is all relative to N, is 56. The mass of the compound, total, that blue, is going to be 80 grams. All right, so the next thing you have to do is you're going to have to divide 56 divided by 80. Press enter on the calculator and then press times 100. What percent composition is nitrogen in this compound? Please put in the chat or unmute. If you want to talk to me, unmute, it's fine. Don't mind interacting with you guys. What percent is going to be nitrogen in this compound? Yes, nitrogen is going to be 30% nitrogen. 30% of this compound is going to be nitrogen. Thank you. So I think it's pretty clear when I highlight these like this. You can see where the information comes from. Hopefully I'm not just wasting my time. You can't see those connections there. I know it's a little bit overkill, but I think it might help a few of you guys out a little bit. So 30% of this compound is going to be nitrogen. Yes, it is oxygen. There you go. Thanks, Lena. So 56 is going to be, sorry, my typo here. Oxygen, I meant to say. Oxygen, 56. Wait a minute, 56 divided by 80 times 100. That was nitrogen. Oh, that's what we did. I'm into the nitrogen already. Let's do percent oxygen. What's a percent oxygen? There's 70%. So you guys are like, what the heck's he doing? That's why. All right, so if you just throw in your calculator, you can figure out that it should be 70%, not 30. Jumped ahead a little bit. So oxygen is going to be 70%, 70.0%. So this compound is going to be 70% oxygen. Nitrogen is the next one. So for nitrogen, what I'm going to do, I'm just going to copy all the previous example, copy all the info, Control C, I'll paste it down below, Control V. Why? Because it's going to be very, very, very similar to the last one. This time we're looking at nitrogen. So I'm going to change this to N before I forget. What's the difference is the mass of nitrogen. So I need the mass of nitrogen, not oxygen. Mass of nitrogen is 24 grams. And Emin already told me the percent nitrogen. 24. The mass of the entire thing is going to be 80. Came from the passage above. Divide them both out and multiply by 100. So 30% is going to be devoted to the nitrogen. So this compound is made up of 30% nitrogen and 70% of oxygen. If you add both those together, obviously we should be able, since it's a percentage, both of those values should equal 100. So that's another way you could check it out. So if there's 2 elements or 3, 4, however many there are, they must all always add up close to like 100, like 99.9, or should be 100. Percent composition. Let's do one more example. Does anybody need more time? Anybody need more time? So 10 minutes left, one more example. All right, determination by a formula. So determination by a formula, I'm going to copy the last formula that I had down. I don't care which one. You can pick either one of them. We're just going to edit it again. I'm going to copy it. I'm going to paste this into my determination by a formula. Control V. All right, percent composition. This last one by a formula is going to be the GFM of the element, gram formula mass of the element, over the GFM of the compound, gram formula mass of the compound. So it's very similar to the last one, but you have a small number over a big number. But now you're just looking at a formula, and you're going to be able to derive this information as well. So we'll wrap it up with this last example. I'm actually going to take my determination by formula and press enter so it's all on the same page. Mess with Google a little bit more. Again, I am recording my lessons in case you guys, I am going too fast for you. So feel free to rewatch it if you need to. It says, what's the percent composition by mass of each element in SiO2? So I want to know what percentage is going to be Si, what percent is going to be O2. So starting off, I know it's going to be this formula. It's got to be that formula. So I'm going to copy and paste it. Control C, Control V, copy and paste it. Percent composition you're looking for. And then you have the compound SiO2. I'm going to paste that formula down one more time. Control V one more time. I'm not going to color code as much this time. All right, so the first one, you're looking for percent composition, so a percent of Si. Percent of Si. I need the GFM of the element over the GFM of the compound. Oh, so you have to get that from here. So hopefully you know that has to come from that portion of the question. All right, analyzing this thing right here, we have Si. So below, I guess, I'll press enter again. I'll do the GFM of SiO2. So I'm going to do the GFM of SiO, control comma 2. How many moles of Si are present here? Anybody? How many moles of Si are present there? One. Mass of Si comes from a reference table. What's the mass of Si? Anybody? Si is it's a metalloid. Si. Mass of Si comes from right there. So that should be 28.1. 28.1. Multiply those two together, you get 28.1. And then you have oxygen. How many moles of oxygen are present? Anybody? How many atoms of oxygen are present? Please throw it in the chat or on mute. All right, no one's talking to me. Thanks, Eta. Mass of oxygen, anybody? Quick we get done, quick you guys are out of here. 16, thanks Nalia. 16.0, now we're cruising. We have 32.0 when you multiply them both together. Add them both together. The total GFM, anybody, is equal to 60.1. Thank you. Thank you. 60.1 AMU. All right, so I don't need the reference table anymore. Now let's just hammer the rest of this out. All right, so the first one we're looking for is for SI. The GFM of the element is going to be 28.1. So 28.1 is going to go right there. 28.1. The GFM of the compound is the total gram formula mass. So that's going to be 60.1. What's the percent of SI in this compound? Anybody? Perfect. There is 46.8. Perfect. I got a few answers rolling in. They all are the same. So 46.8% is going to be oxygen. Last thing, I'm going to copy this whole box I created. I'm going to paste it below. You're saying last thing. This is the last thing. Copy and paste that one below. This is going to be for percent composition of oxygen. So I'm going to edit this again. Again, if you press tab, it's going to bring you to a brand new cell. So percent composition of oxygen. The only thing we're changing is this guy right here. It's not SI, it's going to be O. And I'm also going to change the GFM of oxygen, which is 32.0. What is my percent composition of oxygen? Please put in the chat. The GFM of the compound remains the same. Thanks, Eta. So Eta and Gianella both got the same answers of 53.2%. All right, so that is how you calculate percent composition. Next class, we're going to go through several examples, things I've been in analyzing the percent composition. On that note, that's it for today's class. Thanks for bearing with me. We got through a lot of stuff today. And next time we'll take it a little easier. We'll go through examples on percent comp. I will put the record lesson up there in case you missed something for today's class. But that's it for today. Have a great day. Make good decisions. Stay warm and stay healthy. See you guys later. Have a good one. Bye. See you later, Gino. Have a good day. You too.
Wait, Mr. Brown, when are you gonna post the recorded class?
As soon as it loads, I just posted the. I'll do it. I'll do it right now if you need it.
All right,
like 10 minutes. All right.
All right, sounds good.
All right. We'll see you later.
Have a good one.
Bye, Mr. Brown.
See you later, Olivia. Bye, Edvin.
Showing us that picture.
Oh, no problem.
It was actually really nice because I'm never up early enough to see stuff like that.
Oh yeah, it was nice. That's what we're missing out. 6 o'clock in the morning. It was actually like 6:30.
Night owl.
It's all right. We'll see you later. Have a good day.
You too.
Thanks.